Today I'm going to be talking about modeling with quadratic functions. I'm going to start off with a chart here. Depending on what I give you, you can select a form that you use that's going to make it easier to write this equation of a quadratic. Okay, so the first one is if I give you a point in the vertex, you're going to use vertex form. If I give you a point in x-intercepts, you're going to use intercept form. And the very last one, if I give you 3 points, you can write and solve a system of 3 equations and 3 variables, and you're going to use standard form, which is y equals ax squared plus bx plus c. So we use standard form for that. Okay, so the first one, I'm going to give you a point and a vertex. So we are going to use vertex form. So let's write that down. We have y equals a times x minus h squared plus k. So we have vertex form on here. Now we need to label our information. Our vertex is always h and k. And if I have a point, it's always going to be x and y. So we're going to plug this information in. So our y is a negative 15. We don't know the value of a. We're going to solve for a. X is a negative 7 minus h, so plus 5 squared plus k, 9. Let's simplify and solve for a. Negative 15 equals a times negative 2 squared plus 9. Negative 15 equals 4a plus 9. Subtract the 9. We get negative 24 equals 4a. A equals a negative 6. So we need our a value and our h and our k value to write our equation. So our equation is now going to be y equals negative 6 x minus h, so it's plus 5 squared plus 9. We now have written our equation using a point and a vertex, using vertex form. Our next one is going to be intercept form. I give you intercepts and a point. So let's write down intercept form. So we have y equals a times x minus p and x minus q. So I'm going to label my information. This is p, this is q, and our point is x and y. So let's plug in and solve for a. Y is a negative 18. We need to solve for a. X is 0 minus 9, and 0 minus q, which is 1. Let's simplify. A times negative 9 and negative 1. So negative 18 equals 9a. A is equal to negative 2. We need our a value and our p and our q. So our equation is going to be y equals negative 2 x minus 9, x minus 1. And we've got our final answer in vertex form. All right. Our next one is our third type, okay, and it's writing a quadratic equation using 3 points. Well, in this chart, I've given you 4, but you can pick any 3 that you want to. So if I give you 3 or more points, we can use this method, okay? It says a baseball is thrown up in the air. The table shows the heights y and feet of the baseball after x seconds. Write an equation for the path of the baseball. Then find the height of the baseball after 5 seconds. So what we're going to do is we're going to write an equation. And we are going to use standard form for this one, which is ax squared plus bx plus c equals y. And I'm going to show you why I put the y at the very end. Okay, so what I'm going to do is I am going to, let me select this whole thing and move it over here. Okay, so what I'm going to do is I'm going to pick 3 points. I'm going to use point 06, 222, and 422. And when I have 3 points, they're always the x and the y. Okay. I'm actually going to do the last one first for you. So we're going to plug in this x and y value into the equation. Okay, so we don't know our a value, but we do know our x. Well, our x is 4, so 4 squared is 16, so we have 16a plus 4b plus c equals, which is our y, 22. And we've now written a system with 3 variables. So let's do that for the next one. We're going top up. So 2 squared is 4, so we have 4a plus 2b plus c equals 22. And the very last one, since x is 0, all we're left over is c equals 6. Now, if this looks familiar, this is a system of 3 equations with 3 variables. And now we can write our augmented matrix to use in our calculator. So it's kind of a reminder from chapter 2. So let's write our augmented matrix. So we have 0, 0, 1, 6. Then 4, 2, 1, 22. And 16, 4, 1, 22. Okay, and now what I'm going to do is I'm going to put this into my calculator using reduced row echelon form. So I'm going to go to my calculator, just a little reminder of how to do this. And so we're going to do second and matrix, and then arrow over to edit. We're going to put in our augmented matrix. This is a 3 by 4, and it's going to be 0, 0, 1, 6. And then 4, 2, 1, 22. And our last row is 16, 4, 1, 22. Now that we've plugged this matrix in, we second quit. And then we go back to second matrix, arrow over to math, and we're going to find our RREF, which is B, for reduced row echelon form, and push enter. Now that we have that in our calculator, we have to select our matrix. So we go second matrix, select number 1, and we push enter. And now we have our answer. So negative 2, 12, and 6 is our A, B, and C. So I'm going to write that down. Our A is negative 2, our B is 12, and my C is 6. So now we can plug this into the equation, and we've got our function. So we have y equals negative 2x squared plus 12x plus 6. Okay, so that is our equation. Now, the second part of this is to find the height of the baseball after 5 seconds. Well, time is our x value, so we're going to plug in 5 into our function and determine that we get 16 feet. We can use our calculator for that. So we don't have to solve the 3 by 3 by hand. We just use our reduced row echelon form. Okay, I have one more example for you. This one is using quadratic regression. This sounds extremely familiar because we've done linear regression before. Quadratic regression has the same steps as linear regression, except that instead of pushing linreg, we're going to push quadreg. So it's the same steps. I'm going to show you what these steps are in case you've forgotten. So it says, the table shows fuel efficiencies of a vehicle at different speeds. Write a function that models the data. Use the model to approximate the optimal driving speed. So what we're going to do is we're going to use quadratic regression to write a function. Okay, so let's pull up our calculator. First thing we need to do is we need to put in these values. So we're going to go to stat, edit, and we're going to put it into our table. So we do 20, 24, 30, 36, 40, 45, 50, 56, 60, and 70. Okay, and then we arrow over and we do our y values. 14.5, 17.5, 21.2, 23.7, 25.2, 25.8, 25.8 again, 25.1, 24, and 19.5. So we have our information in here. Oh, I put 195. Let's do 19.5. Now we have our information in here. We have to go to Stat, arrow over to Calc, and go to Quadratic, because we're doing quadratic regression. So we're going to do number 5. Okay, and we're going to go to Calculate, enter until we get to Calculate. And it will calculate, and it's given us our A, B, and C values. So our equation for this one is going, we're going to use, all of these to write our equation. So I'm going to put that, let's write that down right here. Y equals a negative 0.014x squared plus 1.37x minus 7.14. So here is our function. So that's our function. So that was the first part of our problem. So let's go back. And it told us to write a function. So let's write that down again. .714. Let's double check that. Yeah. Okay, so now we've written down the function. Our next one says use the model to approximate the optimal driving speed. Well, optimal means maximum, so we're going to look for the maximum. And driving speed is our miles per hour, so it's the x value. So we're going to look for the x value of the vertex. So what we're going to do is we're going to take this equation and we are going to graph it. So we're going to go to y equals, and we're going to plug in our equation. Negative 0.014x squared plus 1.37x minus 7.14. So we're going to plug that in and we are going to graph this. All right, now we need to be able to find the vertex. We have to be able to see it. If it shows us something like this, like a line, we have to zoom out. So we hit zoom out, which is 3. Let's arrow over a little bit. And I'm going to push enter. Let's zoom out. Let's see what that looks like. Still not quite being able to see the vertex, so let's zoom out again. Zoom 3. Move over a little bit more. Let's see how that looks. Can we see the vertex of this parabola? There we go. We can see the vertex. So what we need to do is we need to find the x value of the vertex, which is our maximum. So we're going to second trace, and of course maximum, which is 4. And we have to get our cursor to the left of this, to the right of the vertex, and then we are going to guess. Okay, and now we have found out that our maximum x value is about 48.9. So about 48.9 miles per hour is our optimal speed.